their key findings in the beginning of the report is that a best management practice implementation may extend the life of the lakes, but it would not necessarily reduce the phosphorus loading or concentration you have in the lake unless something is done about the sediment, because the estimate they had for the sediment was that the phosphorus loading you had from that sediment was approximately equal to all the annual tributary loading. And if you look at the numbers provided in the Phase 1 study, I believe they used AgNIP to come up with their values, and then the Lake Ponset Watershed Project used Russell. That's 35,000 to 45,000 pounds of phosphorus that will come from the sediment back into the lake over that time period. Now, that was not something that was addressed in the watershed project, Lake Ponset Watershed Project, nor was it addressed in the Phase 1 diagnostic study. They only have the one page on the sediment, and it's just about the volume. It's not about the potential for that sediment to contribute phosphorus there. Now, given that this was in response to a total maximum daily load, there may have been some limitations in how they could conduct that study or what they could do, but you're cutting off this amount here. And what we want to measure is the components here, are dissolved organic phosphorus, particulate organic phosphorus, insoluble phosphorus, and dissolved inorganic phosphorus, but those are related to how much actually comes off of that sediment.
Okay. Well, I'm still kind of interested in the year 2007.
Okay.
Do you know what the total phosphorus was in the lake in 2007 in this year when we didn't have any input from from the Big Sioux River, and with all of the work done to reduce the phosphorus levels?
That would be Exhibit 12. On Exhibit 12, I basically, again, using the data from the SORAT database and basically the time frame that was collected in, have a series of measurements that were taken associated with total phosphorus by year. They start in 1989, so we have a level around this is in milligrams per liter, so about 0.28, 0.275 milligrams per liter. This is before a lot of this work has been done. We go through the time period. You can see 93, 94. There's a lot more lines on the graph. This is during the time period when the data was being collected for this Phase 1 diagnostic study. The corresponding weather during that time period is it's very wet. We have a lot of water flowing. We have a lot of water coming into the system that's here. You'll notice the levels are in the range. Let's see, 1991 we're about 0.15, 92 we're down to 0.06, 93, 94 they range somewhere from about 0.05 up to about 0.15. 94 we're below 0.05, so really good there. We got 0.04, but again, there's a lot of water coming in during this time period to dilute that quite well. Up to towards the end of the year about 0.2, then big gap. Then there's some data that's taken in the year 2000. We have two data points, one from June and I believe the other from August. The early one is about 0.07. The late one is 0.25. Another gap. We have one data point collected in 2003. That's about 0.06. But then if you look, this is about the time when we have a lot of the stabilization. People are practicing these best management practices. It looks like, okay, the phosphorus levels in the lake are fairly low, but if you just kind of look across that last set of data, you can see that they're increasing. 2007, they're back up around, what is it, the early one's about 0.17, and the late one's about 0.23 in there. And so you can see, 2007, we don't have flow from Lake Albert. We don't have flow from the Big Sioux River. We have a limited amount of runoff that's there, but at this time, shore stabilization has occurred. Best management practices have been implemented. There are many things that have been done in the watershed to reduce the amount of flow coming in from that erosion, from that runoff that's there. The data that was available from EPA, I've got up through 2008, and then of course it's back to that about 0.23 amount in the lake there.
Well, and then correct me if I'm mistaken, but it appears to me that there's a trend of total phosphorus increasing in Lake Ponset as the water levels decrease.
Yes. I mean, visually you can see, ignore this stuff over here because we haven't done all of these these stabilization projects and other things, but you can see that it slowly creeps up and reaches a background level somewhere around 0.23.
Now, in a naturally occurring lake in the state of South Dakota, is there a amount of phosphorus that just naturally exists?
Depends on what the lake originally came from in terms of the soil. One of the greatest issues that have come before this board before and before a number of states is when the EPA sends out some guidelines. The latest one, selenium and arsenic, are two selenium, S-E-L-E-N-I-U-M, and arsenic, are two that have come up, and the concern is that EPA sometimes sets a particular regulatory limit, which is so much lower than what our natural background level is. So one of the questions that has come up, and it is a current topic that is causing great concern, is what could be the natural level that these lakes are at based on their age, based on their geological origin. The state of Minnesota, in their development of standards, actually looks at what's called this one I'm not sure if I can spell for you, Omernick, O-M-E-R-N-I-C-K, geographic regions for the lakes. And that looks at, like the map behind you, the geological conditions which are there, the amount of rainfall that occurs, the types of vegetation that are present, but it's a geographic way to split each of these up into a similar type of lake. And so I know they have some for their glacial lakes, which are located closer to our border up by Big Stone, and then a little further north from there. But they split up all of their different recommendations for phosphorus based on that Omernick region in their reports.
So would a glacial lake, like Lake Ponset, one that was not created by a spring, would that have a higher phosphorus?
Yes, it does.
And now how about a lake's position in a chain? Now, would a lake at the beginning of the chain have a higher phosphorus content, or would one near the end of the chain have a different phosphorus content?
The one at the end of the chain is basically if you have a whole set of like little teacups, you can keep washing material out of the first one into the second, into the third, into the fourth, but then once it's down to the bottom cup, it's not really going anywhere unless it's got a flow to carry it out of there as well. So you should see less going down to more.
So in a system like Lake Ponset, during a low year, when there's no ability for the water to flow through, which is by the nature of the fact that the gate doesn't let any water out, would the phosphorus levels increase?
Yes, the sediment will continue to feed that. There is relationships. I looked at a number of them just to look to see what that concentration might go to depending on what the phosphorus species is. But phosphorus is an extremely complex absorption species. It is not well explained by simple geochemical relationships. The person I worked for at Kansas State University, Paul Schwab, he's the former, I can't remember what the name is, but Soil Science Society of America Physical Chemistry Unit Division Chair, and he's written numerous articles on phosphorus. It was something that's still researched a lot today just because of how complex phosphorus is.
Now, in this TMDL that you keep referencing, did they have a particular goal or endpoint of phosphorus that they were interested in reaching?
It's not based on the phosphorus, not really. There was a reduction that they were looking at. Their goal or endpoint they were looking for was 158 tons of total lake algal biomass.
What exactly does that mean?
I assume it means if you figured out how much algae there was in the lake on a dry basis, like you were able to suck it all out of there, dry it down, and weigh it, it'd be 158 tons.
Do you know if this goal has been reached?
I don't know. I don't know. The link to that was phosphorus.